Welcome you all. Today we will discuss about the nonlinear optimization. In last video, we have discussed about the linear optimization. So here what is meant by nonlinear optimization means the process of optimization mention an objective function that is nonlinear to its parameters. So in the linear optimization, the objective function is linear to its parameters. So here it is nonlinear. That is the main difference between the linear and nonlinear. In the linear optimization, we have used graphical method, but here in nonlinear optimization, we have to use gradient descent algorithm. So same way, here I am taking one example. That is, the problem statement is there is a one fitness app. Okay, fitness app uses a cost function to predict a person weight loss based on their exercise intensity. Okay, so this app will predict based on your exercise intensity. Here, let us take X is the intensity level. Intensity level means if you are increasing the intensity level, then obviously you will lose more weight. So that uh, relation, it will be predicted by this cost function. So here I said already in optimization, we have to remember some parameters. That is, first one is the decision variables. And constraints. Okay, and if you let us start with this one. The cost function already they have given this out. That is C of x equal to x minus 5 whole square plus 10. So this is the objective function they have given. Now we have to find the best weight loss according to the intensity level of x. So here x is our decision variable. And let us start from this one, x equal to 0. And one more, here we are using gradient descent algorithm. So that is because nonlinear optimization is only solved by the gradient descent algorithms. This gradient descent is the gradient descent algorithm formula is simply we can take some we can take the x new. Okay, x new equal to x old minus alpha into dc of x by dx. Okay, so here is a derivative of our objective function. This alpha is called as a learning rate. Means how our algorithm converging according to this learning rate. Means if you are keeping learning rate is very fast, our algorithm converges to the true solution very quickly, but it's maybe unbounded. So if I am keeping this value is very less, then our algorithm will take a very long time to converges, but it will give a bounded solutions. Okay, and this is the formula for this one. Now, what is the procedure for to implement the gradient descent algorithm is, first we have to take the derivation. So here we need to remember why we have to take the derivation means derivation will tell you either the rate of change it is going towards positive or negative, or it is a constant. Constant means there is no change. If it is a positive means it is the rate of change is increasing. If it is a negative gradient, that is a slope. Okay. If slope is increasing means the function is increasing, and slope is decreasing means we are going towards the true solutions. And if it is slope is zero means no more changes. So here gradient descent means we always focus on the negative slope. That means always we have to searching for the minimum solution. We have to minimize this cost function. That's why gradient descent we are in. Sometimes gradient ascent algorithm also is available. There we have to maximize our objective function. So here our target is only to minimize the objective function means that's why we are using gradient descent algorithm. So before this one, first we have to derivate our objective function with respect to x. Okay. So when I'm derivating this equation, it tends to 2 into x minus 5. Okay. Now let us take, already we have discussed the initial variable. Initially x equal to 0. So if I am substituting x equal to 0 over here, that's simply 2 of 0 minus 5. It is minus 10. Okay. Now this d of is a dc of x by dx is the, that is c dash of x is a minus 10. Now substituting in the x new, that is new intensity level we are obtaining. X old is a 0 and so minus learning rate is 0.5. Okay. And our c dash of x is minus 10. So it will give you answer is it's a 1. Okay. Now right now the x new, that is x1, you can take it as a, that is 1. Again we are substituting this one in the formula, that is c dash of x. Okay. 2 multiplied with, now new value is 1 and minus 5 equal to, it will give you minus 8. So here initially we have taken 0, now we have taken 1 because x new is 1. So this simply we are substituting in this formula. Okay, now what is the x new here is equal to, simply what is the x old? Now x old is a 1 because x1 minus that is 0.1 of minus 8. Okay, so this will give you 1.8. This is a 0.8 plus 1, that is it will give you 1.8. Now x2 or x2, you can take it, x2 is the 1.8. Now same substitute in the c dash of x, 2 of 1.8 minus 5. So it will give you minus 6.4. So then if I'm substituting in the x new, that is old is a 1.8 minus learning rate is 0.1 and minus 6.4. So this will give you the results 2.4. Every time you are checking, the gradient is decreasing. Okay, it is already in the negative direction. So again, we have to continue these iterations. X next one is the x 2 point. The latest x is a 2 point. Again, we have to substitute the c dash of x, 2 of 2.44 minus 5. So this will give you minus 5.12. Already I have done. So directly I am writing answers. So x new is equal to, old is a 2.44 minus learning rate 0.1 and minus 1.2. The change 2.95. Okay. If I am continuing with this one, the next x new, x old is the your 2.952 and then x new after substituting in the above formulas we will get 3.3616. So like this we have to continue, we have to continue up to the differentiation either become 0 or maybe a positive. That means it will like this. If I am taking this is convex function, we are taking this is 0.1, that is a learning rate. The it is the algorithm has to converge like this in the convex. Okay, so here we are getting the minimum, local minimum or global minimum, because here is only one. If it is either increasing or become constant, this is our ultimate answer. Okay, here we are getting the uh, minimized objective cost function of the nonlinear optimization. Okay, so this here, if now in case of if I'm placing a learning rate is very high, okay, if I'm placing learning rate is very high, like alpha is equal to 0.5, then the jump is very rapid because convergence rate is very high, so it will jump like this also. Very quickly we will reach towards a minimum, but may not exist over there because due to the large learning rate, it will always jump here and there. That is, I am calling it as a unbounded solutions we will get. So if we need a bounded solutions, obviously we have to take the very smaller convergence. Otherwise, you can take any value in between the 0 to 1. Okay. So if I am taking, we have to continue up to this one. Finally, after certain number of iterations, you will get x new is equal to 5. Because why I am saying 5? See over here, this function, okay, this objective function, when it will be minimized, when I am substituting x equal to 5. Because c of x equal to 5 minus 5 equal to 0 plus 10. So that's how when x equal to 5, so this here we are getting the minimized cost function. So up to there, we have to continue the iterations. Every time 2.c, you can observe 1.8, 2.44, 2.952, 3.36, later maybe 4.5, 4.7, 4.9. So certain number of iterations. Here I have taken only 5 iterations. It may be 10 or 15 after 20 iterations also. So it will reach the true solution, that is x new equal to 5. So this is the non-linear optimization. So here what we have done, just revised, we have taken the objective function and this is the decision variable. If there is a constraints also, if the example constraints are, let us take x equal to 1 to 5 only, like this, the other 1 to 6 like this. There is a constraints also we can mention. Here there is no, this is unconstrained mode. So no more constraints over here. And we have started with the differentiation. Whatever the objective function was given, just we have differentiated, then substituted the, let us take the one x equal to 0. We started with the 0 and we have updated to the gradient descent formula, in gradient descent formula for finding the x new value. Likewise, we are repeating the number of iterations. At the same time, we are checking the our gradient is negative or positive. So always it is showing the negative. So we are going to the true solutions. And finally, we have obtained our answer. So that C of x equal to, our answer is the 10. So this is the answer for the, if you are using highest intensity level, we will get the weight loss like this. This objective function of the weight loss. So this is the is also called as a single variable because variable is only one. This is the variable. So it is called as a, simply I am writing over here, single variable non-linear optimization. Non-linear optimization. So now next let us discuss about the multi-variable. Multi-variable means here we have two variables. multivariable nonlinear optimization. Okay. So here directly I am writing the objective function is c of x comma y equal to x minus 2 whole square plus y minus 3 whole square plus 4. Okay. So this is the multivariable nonlinear optimization. Second, this is the objective function they have given, and these are the decision variables x and y. Two variables they have given. That's why we can call it as a multivariables. And here the same procedure you have to follow. First one is that we have to differentiate dc by dx with respect to x. Then your answer will get x minus 2. And if I am differentiating with another variable dc by dy, you will get 2 into y minus 3. Let us take the initial x value is 0 and learning rate is the 0.1. Here itself also initial value is y equal to 0 and learning rate also I am taking 0.1. So just substitute it. You will get minus 4, right? dc of dx. Here you will get y equal to 0 means minus 6. Now substituting the x new value. X old is the 0. X old minus alpha into dc by dx. This is the formula over here. And here y new equal to y old minus alpha into dc by dx. dy, sorry. Okay. Now this is x old is a 0 and minus 0.1 is minus 4. And here 0 minus 0.1 to minus 6. So you will get over here that is 0.4 and here 0.6. Now these are the x new values. Now again repeat this operation up to the certain iterations. So I am writing direct answers. First is x1 is 0.4. Now x2 I am taking latest new, that is I am getting 0.72. Here y2 I am getting 1.08. If you are further repeating this process, then x3 you will get 0.976 and y3 you will get 1.464. So finally, like this, your number of iterations, if you are increasing the means, if you are trying for the optimization, then you have to continue for the certain number of iterations. After certain number of iterations, finally it will converges for the multivariable. Finally, it will converge at x and y. Let us see what is x and y. Simply, we can understood where we will get the minimized cost function when x equal to 2 and y equal to 3. Then only we will get the minimized cost function. Okay, that is x equal to 2, y equal to 3. Finally, you will get the answers after certain number of iterations. So this is called as a multi-variable nonlinear optimization. So here we have taken the two decision variables, that is optimized our cost function. Okay, and for the nonlinear, just revise the nonlinear. There are two types: single variable and multi-variable nonlinear optimizations. And this depends on the learning rate. That is here throughout this lecture, I have taken only 0.1. So we may consider, you may consider any one, that is 0.5, 0.7, up to 1. You can take any value. If you are taking very large values, then it can quickly converge to the true solution. But it may be unbounded solutions may be come, but better to take the very smaller values to reach the perfect converged value. Okay. Thank you.